Welcome back. The objectives of this video is to explore more exponential function manipulations and transformations. So in example 5, we're given the graph of f of x equals 2 to the negative x on the grid at right. Now I did that one in black, though, so those are the black dots listed there. And then we want to use the graph to obtain the graph of g of x equals 2 to the negative 2x. So our negative sign still stays the same, but the 2 is going to be some sort of manipulation along the x-axis. And if we go back to our previous notes, we can see that 2 here is like the 3. So that's going to be a horizontal dilation, or shrink things by 1/2 is the result we would anticipate. So I graphed that in red, and we can see our new function. I think I'm missing one of the points, so it's way up here. Looks something like this. So it is going to cross at 0, 1 at the y-intercept. They share the same y-intercept, and then we're just going to skim that x-axis. And so that is a good look at our new graph, g of x equals 2 to the negative 2x. So we do have a horizontal shift here of 1/2. So in example 6, they asked us to show this algebraically. How is this going to work? Can be written in, so our function g of x equals 2 to the negative 2x can be written in the form of h of x equals b to the k raised to the x, using the transformation properties shown in the table that I just showed you. Describe the transformation of the y-intercept from the parent function for g of x and h of x. So g of x is equal to 2 to the negative 2x, which is also the equivalent of 2 to the negative 2 all raised to the x, a power raised to a power. We multiply our exponents. We're kind of undoing multiplication here. And now h of x, well, 2 to the negative 2 is 1/4, so that our new function is 1/4 to the x. So that is after manipulating and rewriting it in a new form. So our red function is also 1/4 to the x power. Our y-intercept, we're supposed to say how that changed. Well, that did not change. The y-intercept on f of x is the same as g of x. It's at 0, 1. And it does not move on g of x or h of x. So it's the same thing on h of x as well. The graph of g of x is a horizontal dilation. G of x is indeed a horizontal dilation by a factor of 1/2. Just as we predicted it would be. Sample 7 says, use the grid at the right to graph f of x equals negative 2 to the x and g of x equals negative 2 to the x plus 3. Label the y-intercept for each function. So let's quickly do f of 0. Anything to the 0 power is 1. So, but that exponent is only on the 2, so it's the opposite of 1, so that does equal negative 1. And then g of 0 is, put 0 in for x, and we get negative 1 plus 3, or we get 2. So we want to describe the transformations of each function. So negative 2 to the x is a change in a. That's going to change our y. We're going to reflect every 2 to the x value over the x-axis. So a positive value will become a negative value. So our original y equals 2 to the x, I've got that here in red. And that function is going to look something like that. So f of x at negative 2 to the x better write that as an exponent at negative 2 to the x. We're going to reflect all these points over the over the x-axis. So at 1 instead of 2 we get negative 2. At 2 instead of getting 4 we get negative 4. At negative 1 instead of getting 1/2 we get negative 1/2. Instead of 1/4 we get negative 1/4. Instead of 1/8 we get negative 1/8. So that's f of x equals negative 2 to the x. And in black we'll do g of x equals negative 2 to the x plus 3. So it's going to be the same as the blue graph, but we're going to shift up 3. So I'm going to call it the blue plus 3. So each one of these points is going to get shifted up 3 units. 1, 2, 3. So 1, negative 2 becomes 1, 1. Negative 1, 0, negative 1 becomes 0, 2. Negative 1, 1/2 gets shifted up 3 units. 1, 2, 3. So we're here. And that graph is going to look like this. So we have a horizontal asymptote at y equals 0. So now our new horizontal asymptote is going to shift up to y equals 3. So we're just going to skim right underneath that. So that horizontal asymptote shifts up 3 units. So describe the transformations. F of x is reflected across the x-axis. So the blue one, f of x, is a reflection across the x-axis. And g of x is a shift up 3 of f of x. The graph of f of x in example 8, the graph of f of x equals 1/3 raised to the x is on the grid at the right. Then use the graph to obtain g of x equals 1/3 x minus 4 plus 2. So our original 1/3 of the x is here in red. We want to find the y-intercept for g of x. Well, we think we're going to take f of x and we're going to shift this 4 units to the right and then 2 units up. So every one of these points is going to shift 1, 2, 3, 4 units to the right and 2 units up. So our y-intercept, I might as well do that in a different color. Our y-intercept now is going to be over here at 4, 3. So every point is going to get shifted 4 units to the right and 2 units up. Every point, 4 units to the right and 2 units up. So even our x-axis is going to be shifted, our horizontal asymptote is going to be shifted 2 units up. So this might help us out a little bit. We're going to shift our horizontal asymptote. That's a little low, but good enough. And so our points are going to come like that. So we're going to skim here and graph. So g of 0 is going to be a little bit tougher to find, but that is going to be 1/3 to the -4 plus 2. So whatever 1/3 to the -4 plus 2 is, or 1/3 to the -4 plus 2 is 83. So our y-intercept is way up here at 83. Describe the transformation. Well, we've done that already. G of x is going to go 4 units right and 2 units up. Sample 9 says graph the function and label the asymptote and y-intercept of y equals -1/2 times 1/2 raised to the x. So we've got something going on here with the y's. Let's take a closer look at this. 1/2 to the x, I can rewrite this. All 1/2 to the x can be written as 2 to the -x. So now we have an a value of -1/2 and an impact on our x, or shifting our x's across the y-axis, and a vertical dilation by a factor of 1/2, and then we're going to reflect over the x-axis. So the -x here is reflect across the y. And this -1/2 here, that's a reflection across the x. And then we have a vertical dilation because we're changing y, so up and down. So the 1/2 is a vertical dilation by a factor of 1/2. So vertical dilation, or a y dilation of 1/2. So what does that look like? Well, in the end, it is going to keep our horizontal asymptote at 0. And we're doing a transformation of y to the 2x. So y to the 2x is going to look something like that, which means if we reflect everything across the y-axis and then reflect it across the x-axis, we're going to have a graph that looks something like this. I kind of missed, but we're going to go through, this is the important point, 0, -1/2 is going to be our y-intercept. We're also going to go through -1, 1, and we're also going to go through -2, 2, and we're also going to go through -3, 4. And you'll see that these points here are actually half as high, okay? Because -1, well, we should have gone through 2, but because of the 1/2, we only went through 1. And at -2, we should have gone through 4, but now we went through 2 because our base was 2 to the x. And at -3, we should have gone through 8, but now we went through -4. So, so there's our dilation there by a factor of 1/2. And in example 10, these are a little bit more straightforward. Write an equation for the transformation of the graph f of x equals 4 to the x, and then explain the transformation. So in A, we're our f of x minus 3, we're replacing x with x minus 3, so our new graph becomes 4 to the x minus 3. This is a horizontal shift 3 units to the right. And here we're keeping our function the same and then just adding 5. It's a vertical shift of a positive 5. And in C, a little bit more complicated. K of x equals 4, the negative 2x. So we have a horizontal dilation of 1/2, and then we're going to reflect across the y-axis. So we're going to reflect across the y-axis because we're moving along the x, and we have a dilation factor of 1/2. And in D, we got a couple things going on here. Negative 3 times 4 to the x plus 1 minus 2. We're going to shift right or left 1 unit. We're going to go down 2, and then we're going to multiply by negative 3. So let's take a closer look at this. We have negative 3 times 4 to the x plus 1 minus 2. So we're going to reflect across the x-axis. That's this negative sign right there that's going to reflect us across the x-axis, because that's going to be a vertical reflection. The negative 2 means we're going to shift up 2, and the x plus 1 tells us we're going to shift 1 unit to the left, and the plus 2 says we're going to shift up 2 units. And then the negative 3 gives us the 3 gives us a vertical dilation of 3. So a lot of stuff going on in that particular one. And we'll get some more practice with these transformations of exponential functions when I see you in class.